And the question says, what is the shaded area? So all these portions is shaded. The square is named as A, B, C, and D. The radius of this is given to as 1 centimeter. So radius for the quadrants as well as for the circle. So if you see here, there are 4 quadrants, and 4 quadrants will make one circle. So the shaded area will be area of the square minus area of one circle is in between, and the 4 quadrants make one circle, so area of 2 circles. So shaded area will be side square minus pi r square. Now the side of the square is given 4 centimeter, so we can substitute that value here, 4 square minus pi r square into 2, because there are 2 circles, right? So 22 by 7 is the value of pi. The radius of the circle is 1 centimeter, and we are multiplying by 2 because one circle in between and the 4 quadrants will make one circle, so total there will be 2 circles. So finally we are going to get 16 minus 44 by 7. I can take the LCM and I'm going to get 112 minus 44. So we get the shaded region as 88 by 7 centimeter square. Next question, question number 8. You can mark this question, very important. Question number 8. Okay, before 8, let me do 6 for you. 6 is also an important question. Question number 6. In a circular table, cover of radius 32. Now, this is a circle. The radius of this is given 32 centimeter. And there is an equilateral triangle being formed. And the question is, find the area of the design that is being formed here. So these are actually segments. We have to find out the area of the segments. So let's name the triangle ABC. The radius is given 32. Now, what we need to do is join O to B and C. So we can easily find out this because this is an equilateral triangle, so all the sides are equal. If sides are equal, they subtend equal angles at the center. Total angle is 360. 360 divided by 3 will be 120. So that angle is 120. Now what we can do is find out area of one segment and multiply it by 3 later. So area of one segment will be pi r square theta by 360. Area of the segment pi r square 360 minus half r square sine theta. That is the formula. So 22 by 7 into radius is given 32. The angle we have found out 120 by 360 minus half r square sine 120. Now here we can cancel off the zeros and 12 goes 3 times. So we are going to get 22 into 32 into 32 divided by 21 minus half into 32 into 32, and the value of sine 120 in my previous video I have explained is sine 90 plus 30, that is cos 30 root 3 by 2. Please remember the value of sine 120 root 3 by 2. Now this I can cancel off 16 times. This 2 and this 32 also cancel 16. So when I multiply 22 into 32 into 32, I'm going to get 22,528 upon 21 minus 16, 256 root 3. Now this has to be multiplied by 3 because area of the segments are involved. This is one segment, so we are going to multiply this by 3. Area of the segment is, this is one segment. So area of one segment. So here we are calculating area of 3 segments. So 22 into 32 into 32 into 3 minus half r square sine theta. This also has to be multiplied by 3. So when we multiply this by 3, this will get cancelled, of course, with 3. This will be 7 times. So it will be 22528 upon 7. So 22 into 32 into 32, we get 22528. 3 and 27 we can cancel. So the denominator is not 21, denominator is 7. So final answer we get 22528 upon 7 minus 256 into 3, that is 768 root 3. That will be the area of the shaded portion as per the question. Moving on to question number 7. The figure is of a square right? And with each vertices, what is happening? Drawing a circle. So we have a circle. The 4 circles are going to touch one another. From each of the vertices, we have to repeat the same procedure like this. Now there is a portion that is left at the center. The question is find out this area that is being formed, that is left out. So this is the square ABCD. The square is having a side of 14 centimeter. The side is 14 centimeters, so radius obviously will be 7 because the total is 14. So this 14 is getting divided equally into 2 parts, 7 each. So radius is going to be half of 14, 7 centimeter. So shaded area is very simple in this case. It will be area of the square minus area of the 4 sectors. Now the 4 sectors is actually equal to 1 circle. So we can say the required area will be side square minus pi r square. So the side is given 14, 22 by 7, radius is 7, cancel out the 7s. So finally we get answer 196 minus 22 into 7 will give us 154. So we get the answer as 42 centimeter square. If you understood this, then we move on to question number 8. That's, as I informed earlier, it's a very, very important question. So it is speaking about a track. It's a racing track. So we are having a racing track with semicircular ends. We have seen these tracks straight for some portions and then it goes around in a semicircle. right? So we can consider this as straight to a certain extent, and then at the two ends we are having semicircles. So the distance of these tracks are given 106 meters. So 106 meter is the length of this track. The width of this track is given 10. The width of this track is given 10 meters. So 10 meter on either side, right? And the distance between the two inner tracks is given 60. This is given 60. The first is find the distance along the inner track. What do we have to find? Distance along the inner track. So when we look at the distance along the inner track, so we know that this portion is 106, this portion is 106, and the inner track will have two semicircles at the end. So two semicircles at the end means one circle, so that is 2 pi r. And what will be the radius? The diameter is 60, so radius is going to be 60 upon 2, that is 30. So distance along the inner track will be 106 plus 106 plus two semicircles, that is 2 pi r. So 212 plus 2 into 22 by 7 into radius, we will assume as 30. So solving this further, we get 212 plus 44 into 30. So 1320 by 7. When we take the LCM, this is going to be further solved as 1484 plus 1320. So the final answer we get 2804 upon 7 meters. That is the distance of the inner track. The second part is to find the area of the track. Second portion is to find the area of the track. Now, where is the track? The track is here. I'm shading it. This entire portion is your track. All this is your track. So this is what I need to find out. So here we know that the inner radius is 30 and the width of this track is 10. So the outer radius will be 40. So this is very important here, that the inner radius is 30 and there is a width of 10 here. So the total capital R from point O to the outside portion will be 30 plus 10, that is 40. Okay, so this is forming a rectangle. Here it's a rectangle here. This is a rectangle. This is also a rectangle. So these two rectangles can be found. Area of a rectangle is L into B. So two rectangles we have. Plus, if you look at the two semicircular portions, so one on either side, we have two semicircles. So I am going to combine the two semicircles. What will happen is that it will form two concentric circles. And the track is here. And this forms a ring. An area of a ring can be found by using the formula pi capital R square minus pi small r square. Outer circle's area minus inner circle's area. Okay, so when we calculate the shaded region, the rectangles are there, L into B. So length is given 106 and the breadth is 10. Plus the tracks on the two ends are semicircular. When they combine together, they will form a ring. So this diagram I have drawn to explain to you what a ring is. The two semicircles are combined to form this ring, and area of a ring is this. So L into B into 2 plus area of the rings. So this will be 106 into 10 into 2, because length is 106. Breadth is going to be 10 into 2 plus 22 by 7. Outer radius we have calculated 40, inner radius 30. So this is going to be 2120 plus 22 by 7 into 1600 minus 900, that will be 700. So we can cancel this with 100. So final answer we get 2120 plus 2200. So when we add this, we get the total area of the track 4,320 and the unit will be meter square. So this will be the area of the track, and the first part was the distance of the track, inner track. And area of the track is, the unit will be meter square.